Hello Chem students, I'm super excited to dive in with today's video. Today we're going to be learning all about electron configurations. And so before we even dive in, I'm going to just let everyone know, full transparency, this is a really hard topic to get. However, I am very confident that you're going to be able to get this down with some practice and even asking your teacher for additional support. And so I'm sitting here at home, it's 9 o'clock at night, and I'm just so excited because I know all of you are going to do so well here. So let's go ahead and dive in. So today, in this video specifically, I'm going to be showing you how to draw an electron configuration for nitrogen. So if you look over here at this blurry and not very good drawn element tile from the periodic table, we see nitrogen. I know this is nitrogen because I see the symbol N, which stands for nitrogen. On this tile, it's going to give me a lot of important information. The information that you're probably most familiar with is this number at the top. We call this the atomic number. And at this point in chemistry, we know that the atomic number tells us the number of protons, which is really important information because that tells us the identity of the element. However, in an element or in an atom that's neutral or has no charge, the atomic number also is going to tell us the number of electrons, which is super important for our electron configurations. And so in this case, our atomic number of nitrogen is 7, so nitrogen will always have 7 protons. However, if we have a neutral or a nitrogen atom with no charge, we're also going to have 7 electrons. This is going to come in handy later when we are diving into it. Before we even jump into the electron configuration, I'm going to really quickly show you what one looks like. So on this card, you're going to see the electron configuration for lithium. Lithium's neutral electron configuration is 1s2, 2s1. So let me just show you what all of these different letters and numbers mean. So the first ones I want to point out are these larger numbers here. These larger numbers tell me the energy level. So starting all the way to the left, this number 1 is energy level n equals 1. So energy level 1. And next to it is specifying which sublevel we're in. So in this case, we have S, which is our smallest sublevel that's available to us. So to read this, we would say energy level 1, sublevel S. The next part are these superscripts. Many of you call this like the exponent. However, that's more of a math term. I'm really going to push students to call these a superscript. So if you're ever having a hard time remembering, just know superscripts are like Superman or Superwoman who are in the air. They're above everything else. And so these superscripts here tell us the number of electrons. So this electron configuration gives us a lot of good information. We've recently learned about orbital diagrams, which are really great for understanding how electrons move and where they are. However, what I tell my class all the time is that scientists are super lazy. And so we don't have time to be drawing all those boxes and arrows. And so to go around that, scientists created this super quick hand called electron configurations. So as we move on in this lithium electron configuration, you can see that over here is again our energy level. So now this is the big 2, which just means n equals 2, or energy level 2. And then we're specifically looking at the sublevel S. And inside this sublevel S, we only have 1 electron. So altogether, this makes a lot of sense because in a neutral atom of lithium, we have 3 protons, so we'd also have 3 electrons. So see this. 2 plus 1 equals 3. So these superscripts, when you add them up, is going to give us our total number of electrons, which is going to come in very, very handy later on when we are drawing our own electron configuration. So that's what it looks like. This is what our end product is going to be. Let's go ahead and dive into the good stuff and actually start with our very first electron configuration. At this point, you should have some kind of paper or pen, or if you're really good at electronically following along, you can do that. But this is really a moment where you should be writing stuff down to really obtain and retain this information. So back to our example. Nitrogen, we've already determined that there are 7 electrons. So when we are writing electron configurations, there is this super easy chart that I like to write. This is called the electron configuration chart. And you can draw one yourself. Sometimes, like I provide my students with one, or you can just Google one if you kind of have a hard time keeping it really neat. But if you're in a pinch and you need to make one yourself, I'm going to teach you right now how to draw one yourself. So we're going to start with our S sublevels. So on the left side of your chart, you're just going to go down like this. You're going to go 1S, 2S, 3S, 4S, 5S. Notice how I'm keeping these all aligned really evenly, and I'm giving myself some space. I don't want to put these too close because it's going to be a little bit harder. So we all know after S comes P. But each of these, like I said, each of these big numbers represents an energy level. So P doesn't exist in our energy level 1. So we're going to start down here at 2. So we're going to go 2P, 3P, 4P, 5P. Again, notice how I'm keeping them vertically aligned and giving space in between these different symbols. Next up, SPD. We know that D does not exist in energy level 2, so we're going to start with 3. So you're going to do 3D, 4D, 5D. Ooh, that's an ugly D, but that's fine. And then to finish it up, we have F. If your chemistry teacher's making you go to F, I love them. They're really pushing you because they believe in you. But very rarely in this level of chemistry are we going to go to F. But we put it in just in case our chemistry teachers are feeling a little extra. So this is kind of the outline of our chart. If you can get this far, you've already done 90% of the hard work when it comes to electron configurations. The last part to kind of really make sure that this is super, super clear is adding our arrows. So this is where it gets a little tricky. If you are a perfectionist, you can use an arrow, but you're going to draw arrows just like this. And they're going to just go diagonally so you know which direction you're going. So we're going to connect the 2P and the 3S, so on and so forth. And this took Mr. Adrian a long time to kind of get down, but with some practice you'll be able to do this. And again, if you are just not as good of a writer, that's totally fine. We have those people in the world. You can Google it and there's lots of examples there, or you can even ask your chemistry teacher to provide you with one. So we are all set up to continue with our electron configuration chart. So let's dive in with our very first example. So over here with nitrogen, we've already determined that there are 7 electrons. So I need to show 7 electrons in my electron configuration. So for my sake, I'm going to put 7 electrons here, just so I know that's the total number I need. And as I'm writing it, I'm going to count down. So these arrows, the reason they're so important is it tells me where to start and where to go. So if you're a student that has troubles kind of like seeing a problem and just knowing like, where do I start? This is where to start. This is why the electron configuration chart is so important. So we always start with 1s, always and forever, and we're going to use this line right here. So 1s. So go ahead and write that down with me, 1s. So now we have to start placing electrons. And just like before, like I said, we are going to be putting in these superscripts the number of electrons that are in each of these sublevels. So from our previous lessons, if this also helps, under our S column, you can put 2, because that is the maximum number of electrons that fit in our S sublevel. You can even put 2e minus sign, so you know that we're talking about electrons. For P, we know that is 6 electrons. For D, we know that is 10 electrons. And for F, we know that is 14 electrons. Cool, so let's go back to our example. 1s. Well, I can only fit 2 electrons in here, and I need to fit 7. So I'm just going to go ahead and fill up this sublevel right away. So I'm going to put a 2 here. And to make sure that I'm keeping track of how many I have, I'm just going to do subtract. Boom. I have 5 more left. So let's continue. Next, we're going to go to our second arrow now. This arrow is crossing through 2s. So I'm going to write that down. 2s. And again, we know that S can only fit 2 electrons. I have 5 electrons available, so again, I'm going to fill these up. So S is going to have a full 1, minus 2, leaving me with 3 left. Now, the instant urge, and this is the biggest misconception or the biggest mistake that I often see in electron configurations, is as humans, we want to kind of continue the pattern. So we see 1s, 2s, and then we're going to write 3s. 3s would not be correct here. That is why these arrows are so important. So when you move to your third arrow, you are going to write down the energy level and sublevel that you hit first. So when you're going down here, you're going to hit 2p before 3s. And the reason that we're writing 2p before 3s is because 2p has less energy than 3s. And we know that in atoms, the lower the position, or the closer to the nucleus that the orbitals and sublevels are in, the less energy it has. So instead of writing 3s, even though you're going to want to, you're going to write 2p with me. So 2p. And if I look, as my quick reminder, 2p, sublevel p, can fit 6 electrons. Well, I only need 3, so I'm just going to go ahead and put the rest of my electrons in p right here. This isn't going to fill it up. However, it is going to tell me that means I am finished now. So the goal is to get down to 0. It tells you that you're finished. And then this is your final product. 1s2, 2s2, 2p3. So this entire video took some time to go through, just because I was taking my time to really show you exactly what to do. However, with practice, you're going to be able to draw electron configurations in a matter of seconds. Especially as you start using this chart a little bit more, it's going to go by quicker and quicker. So if you are feeling a little less confident right now, that's totally fine. We're learning right now, and that's kind of what learning feels like, is it feels challenging. But to get past that feeling, you have to dive in. You have to take that academic risk and try until you get it right.